Hello, today we are going to look at the angles in a triangle, and the fact that we need for today is that there are 180 degrees in a triangle, or the angles in a triangle always add up to 180 degrees. If we add up our 140, our 25 and our 15, we get 180. We will look at where this fact comes from in the long run, but for right now we just need to have it in the back of our minds. Just like there are 180 degrees when we rotate around a straight line, there are going to be 180 degrees in our triangle. That is, we add up our angles and we always get 180 degrees. So let's see if we can use that to solve some problems. So if I have the angle ABC, which I've labeled X here, I don't know what that angle is, but I do know that the other angles in this triangle are 80 and 60, and I'm asked how big is the angle X. So the way that we would write that is how big is our vertical lines here. These will in the long run be called modulus lines or distance lines. So what is the size of the angle ABC? So we start at A, we go to B, we go to C, and the angle in between those is going to be the angle we're looking for, the angle X. So how are we going to work this out? Well, we know that all of the angles in our triangle add up to 180. So that means that X plus 80 plus 60 must add up to 180. If we add up all the angles in our triangle, we must get 180 degrees. Now I can add up my like terms, and I have X plus 140 is equal to 180. Rearrange my formula, and I get X is equal to 40, and I remember my degrees symbol. So this is how we can use this fact to solve our problems, but we can also mix it in with tools that we already have in geometry, like the fact that we've already mentioned that there are 180 degrees in a straight line as well. So let's have a look at this question here. We have our triangle, and we also have the line, the base of the triangle as it would be normally read, continuing out to the point L. So we're asked about the angle NKM. So we go N to K to M. This is the angle we've labeled X, but we know that we could also write that as the angle M to K to N. That would be describing exactly the same angle. We could also call it the angle at K, but we can see that could get a little bit confusing because do we mean X or Y? So we need to be careful of this way of writing an angle. If we see it, we need to be very cautious as to which angle is being referred to, because we could also have this big angle of 180 degrees here. So we need to be careful of this way of writing it, but you can sometimes see it in some circumstances. Like you could have the angle N here and be fairly confident that they meant 100. Now, regardless, these two are the most, should be an angle symbol in here. These two are the most important, and then we can always label our angles using letters or some form of label. So we're looking for the angle X. How would we find it? Well, we can see that we have the angles. The angle we are looking for, X, is inside of a triangle, and we know that all of those angles must add up to 180. So 100 plus 50 plus X must all add up to 180 degrees. So that means 150 plus X is equal to 180. We add up our like terms, which I should mark here. So we add up our like terms, and then we're going to rearrange our formula so that there are only X's on the left-hand side and only numbers on the right-hand side. And I get X is 30 degrees. So I now know that X is 30 degrees, and I can put that in on my diagram so it's easier for me to keep track of what I know. And then I'm asked for the angle NKL. So N to K to L. We walk from N to K to L, and that's going to be this angle here, the angle we've labeled Y. Is there another way that we could write that angle? There is. We could say that we went from L to K to N, and that would also give us the same angle. It's important that we are reinforcing that because these ways of labeling things take a little while to get used to. And we can see lots of different versions of them in the exam. As I say, we'll skip the version where we could call it K, because that might be confusing in this setting. So that's the angle Y we're looking for, as we've labeled it in the diagram. And how are we going to find it? Well, there are a few ways we could find it, but the one that links back to what we have done before is that we know that X plus Y must add up to 180. Let's put a question mark there. So we have X plus Y must add up to 180. Well, I know that X is 30. I found that already. So 30 plus Y must equal 180. Now I just need to rearrange to get the letters on one side and the numbers on the other. So Y must be equal to 150 degrees. So I now have that in, and I'll label that in. That's 150 degrees, and that's my 30 degrees. When we're trying to solve these problems, particularly when they get more complex, it's important to fill in the diagram as we go. It makes an enormous difference to our ability to see what tools are available to us. Now, finally, we want to remind ourselves, we know that our big vertical lines here, just like with our angles, mean the size of something. So this means the size of, so these big lines here mean the size of the angle N to K to L. The size of the angle from N to K to L was our value for Y. So this means the size of the distance, effectively, from M to N. So M to N in the diagram, the distance from M to N is just the length of the side of this triangle, is going to be 5 centimeters. So we just read that directly off the diagram. So that means the distance from M to N. We may write that in. That's the distance from M to N. And it's important we understand that language, that this means the size of, or in this case, perhaps more usefully, the distance between. And then the same symbol are distance from, or our size of, M to K. Well, M to K we're labeled as 15 centimeters. We can just read that directly off in that circumstance. Now, in this problem here, we're asked for the angle GEF. So we go to G, we walk to E, we walk to F, and it's the angle in between there. So we're looking for that angle X. So how are we going to find it? Well, right now, we don't actually have enough information to find it directly. We have two angles inside this little triangle. So X is inside the triangle EGF or GEF, whichever way you want to say it. And we don't know this third angle here. So we'd need to know two of the angles to find the third one. So how are we going to find it? Well, there are two ways that jump out at me here. We know two of the angles in the bigger triangle. So we might be able to find the overall angle here. That might help us. Another thing that we could do is, if we know this angle here is 120, well, we know if we call this angle here, we'll say little a, then if we found A, we'd be able to have two angles in our triangle and find the third one. So there are several different ways that we can approach the question. And in geometry, because there are lots of different tools available to us, it's very important that we are constantly telling ourselves the story. Is there more than one way I could approach this problem? Could I think it through in more than one way? And that's the skill we need to develop. So let's start off by doing it like this. So I can see from my diagram that I need to find this angle A, and I know that A plus 120 must add up to 180, because this is a straight line here. So if I rotate all the way around from here, around to here, I must end up rotating through 180, because it's a straight line. So rearranging that equation, I should say, I end up with A is equal to 60 degrees. And now I know that that's 60, so I fill that in. So I fill in the information I have on my diagram. And then I can say, well, X plus 70 plus 60 must all add up to 180. So X plus 70 plus 60 must all add up to 180, because there are 180 degrees in our triangle. So we add up our like terms. X plus 130. To add up to 180. Rearranging. X must be equal to 50 degrees. To point out, you could also find this missing angle here. We'll call that little b. We could also find this missing angle here, and if we worked out the overall angle F to E to H, you would be able to find out this larger angle here. And you're able to find out the angle little b because you know this is 120 and 50. So you'd be able to work out the angle b. You're able to work out the larger angle from the outside, from the big triangle. And x plus b must add up to this bigger angle. So that's another way of approaching the problem. And again, it's important that we're able to look at this problem and say, what are the different tools, what are the different ways of approaching this problem that I can use to figure it out? Now, finally here, we're asked for the size of, or the distance between F and H. So F is here, H is here. And I'm not given that distance directly. I'm told that the distance from F to G is 4 meters, and the distance from G to H is 2 meters. But these are just the distances along a line. If I add the two of them together, I must get the total distance between F and H. So that must be the same as the distance from F to G plus the distance from G to H. So that's just going to be my 4 meters plus my 2 meters would give me a total distance of 6 meters. So that's going to be my distance from F to H. And that's what we need for now.